All right, ladies and gentlemen, so here we're going to focus in on how to interpret the derivative. So we've been doing a bunch of work on how to take the derivative, and we've been doing a little bit of problems like in context, but here we're really interested in how to interpret the derivative and what it means in real life. Because after all, there's no point to learning all this math if you don't know how it works in real life, right? Now, as you can see, our real life problems, and this is kind of contrived, but our real life problems often don't have nice round numbers that we like to see. So for example, this one has a little decimal in the exponent. We could take this derivative by hand, but we in fact don't need to, because I'm going to show you how to take these on your calculator. So the thing you want to make note of here, and if you have your calculator, do this along with me too, is the keys that you want to press are math and then 8, and n derivative is the name of this function. So I'll show you how to do this. So I'm going to hit the math button, which is here, and you're going to be using a lot of this menu this year, by the way. Scroll all the way down to n deriv, that's number 8, so you can also hit the 8 key. And I get this little screen here, like I showed you in your notes. And you're always going to type in x for the variable, and then I'm going to type in my function in terms of x. So I'm going to type it in exactly as I see it. So there's my function. And notice I use x instead of t. As my variable, you'll always use x. And then it's going to be like x equals. And this is where you tell it where to look. So here I'm going to say x equals 5 because I want b prime of 5 in the problem. So here's my result. And I would say make sure you can reproduce this as well on your own calculator. I get 0.866. And on the AP exam, we're going to round to 3 decimal places. So I would say, to start my answer here, I would say b prime of 5, just like it says in the problem, right? 866. Okay. And now notice we're not done here. So the real work, first of all, this n derivative function is pretty nifty, so make sure you can do that. But the real work here is to figure out what this means. So it says find b prime of 5 and explain its meaning in the context of the problem. So this is a really common and honestly pretty easy FRQ question that you can get. So here, notice like I didn't have to really read the problem to find b prime of 5, but I do have to read the problem to interpret, right? So b of t gives the number of tiers. So I would annotate, so I would say like this is my y, right, is the number of tiers. Whoops. And then for t minutes of working on your calculus problem, so maybe you can relate, and that's my x, right? So I would annotate my y and x, because that's going to help me figure out my units on this problem, okay? So to explain its meaning in the context of the problem, the way we want to do this for the AP exam is specific. And I have what is a rather unfortunate mnemonic here. The mnemonic is NUT, N-U-T. And this stands for number, units, time. So to get full credit for a good interpretation in the AP exam, you need all 3 of these things. So let's see what this looks like. And I'm going to actually do these out of order to write a good English sentence. I'm going to start with at t equals 5 minutes. So this is my time. So I'm going to say which x this is happening at. Because remember, what I really have here is I have a curve, and I just found the slope of a curve at a certain point, t equals 5. But this slope changes depending on where I'm at the curve, so I have to give my time. So this is my time. So at t equals 5 minutes, so I say the number of tiers is increasing at a rate of 0.866. So here's my number. And notice I said increasing here, which is better than changing, right? I said increasing because my derivative was positive. If it had been negative, I would have said decreasing. We already know that, right? So I have my number, my time. I need a unit here. And my units are always going to be, and you've known this about slope for a while now, my units are going to be in units of y per x. So here, we're talking about tiers per minute. So here's my interpretation. I have number, units, time. I'm going to check that I have all 3. And I do, right? So I have t equals 5, my number 0.866, and then my units is tiers per minute. Okay? So this would earn you full credit on the AP exam. Okay, so all I really did is punch something into my calculator and then explained it in a certain way. Let's look at a couple more here. So here we have so many tiers that now we're running away from our calculus problems, and we have a velocity function given in the table. So notice here we don't have something we can punch into my calculator, but it asked me to estimate v prime of 17. So here we're going to estimate the derivative using the data of the table, and then we're going to again interpret it in context. And the way we're going to estimate this, notice my t is 17. Well, my t of 17 is between these two values, right? From 12 to 20 would be 17. So to estimate this, well, this is something you already knew. You knew before you even came to me. To estimate this, I'm going to take v of 20 minus v of 12 over 20 minus 12, right? So that's something you already knew how to do. So here's what I get when I pull those values out of the table, and when I do that math, I get 5. So 5, I could say v prime of 17 is, we'll use squiggly equals here, that means like I'm estimating, roughly 5. And my units on this, I can label it right away. 5, notice we have meters per minute and minutes. So I'd say 5 meters per minute. You can say squared. If you're a physics person, you probably write that. Or you can say meters per minute. And then my interpretation, numbers, units, time again. So I'd say my velocity, your velocity as you run away from calculus, is increasing because, again, my derivative was positive at a rate of, here's my number, units, time. Rate of 5 meters per minute at t equals 17. Okay, so two different ways I can find a derivative. I can estimate or I can use my calculator. Either way, the way I interpret is the same. So now we're running away from our calculus all the way to Six Flags. And here I give you two functions. And here is where you have to read very carefully. So notice I'm told that this is a rate. This is the rate at which people are entering the park. And this is the rate at which people leave the park. Right? Anytime you see rate, probably ever, but definitely in AP Calculus, anytime you see the word rate, I would draw a box around it, circle it, whatever you like to do. That's always going to be a keyword. Okay, so the key to this one is that these are already derivatives, right? These are already rates of change. So here I have to do almost no work. So it tells me that h of t is e of t, so the rate that they're going in, minus l of t, so the rate that they're going out. And then it tells me to find h of 17 and interpret its meaning. Well, h of 17 is going to be just e of 17 minus l of 17. And then I can just plug these into my calculator. So I don't have to take a derivative here because that work is already done, right? So I can just plug that into my calculator and I'll just give you the result. So I get negative 380 and some change here, negative 380.28. Okay, now the interpretation is the trick. So my result was negative. This, by the way, is called a rate in, rate out problem because we have a rate people are entering and a rate people are leaving. And we're going to study a lot more of these in the next little section here. So what I found is that this is negative. Well, h is the rate in minus the rate out. So this means people are leaving the park if this is negative, right? So more people are leaving than are joining, so the number of people in the park is decreasing. So again, we're going to do numbers, units, time. So I say the number of people in the park is decreasing because my result was negative, right? So it is decreasing at a rate of, and then I dropped the negative because I already said decreasing, 380.281, so that was my result. And then I need a unit. And notice these were both measured in people per hour. So my units is I can say people per hour per hour. Okay, so again I have my time, my number, in my unit. So that's my interpretation here. Again, we're going to do more work on these rate in, rate out problems in the next section. For now, let's recap. So the three ways we saw derivatives here. Notice we didn't really have to take a derivative here. So when you're expected to use a calculator, estimations, and this is just using our difference quotient or slope formula, and then they're just given to you. So the work in these FRQs is often interpretation, and it's very rare that you have to do some big long derivative on one of these, so that should put our minds at ease a little bit.